Hey guys, welcome back to my YouTube channel. Today I am talking about be seen 3D printed bike lights with Fusion 360. When I am out and about on my bicycle at night, I like to be seen. The more lights, the better. I do have some USB rechargeable lights and they work really well. My bike is electric and it has of all things a USB port. I am thinking along the lines of having a bike lamp as say a reserve lamp. It could run off either AA or AAA batteries or USB. The trips I make on evening are no marathons, but a time or two I have forgotten to charge my lights or something, and here in the UK having no lights carries a hefty fine. My cycle helmet has a built-in rear LED lamp, so my thinking is with a reserved front lamp I have got all bases covered. Not sure how much it would drain the battery yet, but should be oak over short distances, and the LED lamp that I am going to use is 5 watt with 9 LEDs and on 4 into AA batteries. Even they could be rechargeable. The LED lasts for 5 watts. After seeing the lights, it's time to get on with the design. Further supplies which are used for this project: Kitronic 5V LED lamp kits, on off switch, micro sub connector, 4 into AA battery holder, buck converter, Fusion 360, 3D printer, 1.75 mm PLA black, acrylic offcut, 2NO, 3 mm Allen head bolts, 6 mm long, hot glue. Step 1: bike lamp design. The main lamp body. This lamp doesn't need to be anything fancy design wise. The LED is soldered PCB is square shaped, as is the battery holder, albeit smaller in diameter. So this design will be a simple oblong square shape. Using Fusion 360 and using the top plane, I create a square of 46 mm, then offset this outwards by 2 mm. This will be the wall thickness. I want to slot a piece of acrylic into the oblong to protect the LEDs, so I make another center square at 38 mm. This will create a lip when we drop the piece of acrylic in, or clear plastic sheet of cut, whatever I have available. Step 2: creating the end cap for the lamp. After creating a new sketch and using the 2 mm top of the wall to sketch 2, I use project to highlight the top of the main body of the lamp. Selecting the inner line of the wall, I offset this to 0.3 mm inboard. This will give the end cap enough clearance for a snug fit. Hopefully then offset again to 2 mm to create the inner wall of the lid. Sounds a bit confusing. I will add plenty of screenshots for reference as always. Using the extrude tab, I highlight this inner wall, then extrude down to 5 mm, creating a new component as we go. Then the main section of the end cap can be highlighted and extruded to 2 mm. On the base, I need to create a slot for the mini USB connector, which will be internal, and also a slot for the switch. This will also be fitted from the inside. Step 3: lamp electrics. The bike lamp will have a dual feed. It can either be run off the inboard batteries or the bike's own battery via the onboard USB port. The switch I have has 2 soldering points for the center poles and 2 poles for each way, which is handy for this purpose. I will use one of the ways from the batteries. I need to install a buck converter to drop the 6V battery power down to 5V for the LEDs. So from the converter, the 5V and GND from the batteries will go directly to the buck converter in, then out of the converter the 5V will go to the center poles on the switch. The ground along with the GND from the USB PCB are soldered together and then soldered to the GND wire from the LED and sleeved. The same applies to the 5V from the LED. This will have a switched battery feed and also a switched USB supplied feed. Then I can leave the lamp attached to the bike at all times and just switch it off rather than unplug the cable each time if I need it, ever have to use it. The assembly. Step 4: assembling the lamp and designing and making the bracket. I need a bracket to attach the lamp to the handlebar of the bike. I am going to make it a more permanent feature, and for this reason it needs to be more secure, so I am thinking of a clamp based design secured with Allen head 3 mm bolts and washers and lock nuts. To start with, I get the diameter of the handlebar 22.5 mm. Then I select the top plane and sketch a rectangle of 50 into 6 mm. We are looking down on this bracket from a side view. The next thing to do is sketch a circle, then offset it outwards until it sinks into the rectangle we created. Step 5. First test of the lamp at night and assumptions. I wanted to test the light in the dark and compare it to my normal front bike light, and I was pleasantly surprised. The coverage right in front of you, which is really what you want to see for the ever growing number of potholes, etc., was very good, and the light does what it says on the tin. It works very well on its own battery power, and switching over to the bike battery, there was no difference. The clamp works well and holds really good. The height can be adjusted to suit. I quite like the square lamp. It looks radical, a bit like the weapon the Predator has on its shoulder. Well-ish. I didn't realize until I had finished it that I also had a round 5V LED lamp. I soldered the resistors and LEDs as per the instructions and then set about designing a cylindrical lamp as well. The only difference being is that the round lamp only has 3 batteries in a holder, AAA this time, so it will have the same switch and mini USB connector and will be wide, pretty much the same, but omitting the buck converter. The design principles are the same as the square lamp. I cut a piece of 4 mm acrylic for the lens on the CNC machine for ease. I feared I would make a mess cutting on the band saw. The lights look different, that's a fact, and were very enjoyable to make, and with the USB as well as battery option, it could get me out of a situation you never know and save me getting a fine. I might try another lamp at some point with a 9V battery and buck converter. Thanks for looking in.